ಕಾಣಿಸ್ತಾ ಸರ್.
ರವಿ ಸರ್
ಕ್ಲಿಯರ್ ಇದೆ ಸರ್. ಹಲೋ ಕಾಣಿಸ್ತಿದೆ ಸರ್. ಈಗ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್.
ಹೋಪ್ಫುಲಿ ನೆಟ್ವರ್ಕ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗಿಲ್ಲ.
ಮೋಸ್ಟ್ಲಿ ಆಗ್ಲಿಕ್ಕಿಲ್ಲ ಸರ್. ಇನ್ನು ಒಂದು ನಿಮಿಷ ಸರ್ ಅಷ್ಟೇ. ಕಾಣಿಸ್ತಾ ಸರ್. ರವಿ ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್. ಹಲೋ ಕಾಣಿಸ್ತಿದೆ ಸರ್. ಈಗ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್.
ಹೋಪ್ಫುಲಿ ನೆಟ್ವರ್ಕ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗಿಲ್ಲ.
ಮೋಸ್ಟ್ಲಿ ಆಗ್ಲಿಕ್ಕಿಲ್ಲ ಸರ್. ಇನ್ನು ಒಂದು ನಿಮಿಷ ಸರ್ ಅಷ್ಟೇ. ಕಾಣಿಸ್ತಾ ಸರ್. ರವಿ ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್. ಹಲೋ ಕಾಣಿಸ್ತಿದೆ ಸರ್. ಈಗ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್.
ಹೋಪ್ಫುಲಿ ನೆಟ್ವರ್ಕ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗಿಲ್ಲ.
ಮೋಸ್ಟ್ಲಿ ಆಗ್ಲಿಕ್ಕಿಲ್ಲ ಸರ್. ಇನ್ನು ಒಂದು ನಿಮಿಷ ಸರ್ ಅಷ್ಟೇ. ಕಾಣಿಸ್ತಾ ಸರ್. ರವಿ ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್. ಹಲೋ ಕಾಣಿಸ್ತಿದೆ ಸರ್. ಈಗ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್.
ಹೋಪ್ಫುಲಿ ನೆಟ್ವರ್ಕ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗಿಲ್ಲ.
ಮೋಸ್ಟ್ಲಿ ಆಗ್ಲಿಕ್ಕಿಲ್ಲ ಸರ್. ಇನ್ನು ಒಂದು ನಿಮಿಷ ಸರ್ ಅಷ್ಟೇ. ಕಾಣಿಸ್ತಾ ಸರ್. ರವಿ ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ ಸರ್. ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ.
ಹಲೋ
ಸರ್. ರವಿ ಸರ್ Ravi sir, can you hear me?
Yes sir, I'm ready.
Okay.
Yeah, I can hear you.
Okay, fine sir. Maybe network slow ಇದೆ ಸರ್, ಅದಕ್ಕೆ ಆಗ್ತಿದೆ. Okay. ಇನ್ನು ಒಂದು ನಿಮಿಷ ಸರ್ ಅಷ್ಟೇ. Good afternoon all of you. I welcome to today's session. Which is going to be engaged by Dr. Ravikumar, Hosmani. And today's topic actually is the development of nano pesticides for the crop pest management. Sir, can you hear me? Please start, madam.
Hello.
Sir. Ravi sir. Ravi sir, can you hear me?
Yes sir, I'm ready.
Okay.
Yeah, I can hear you.
Okay, fine sir. Maybe network slow ಇದೆ ಸರ್, ಅದಕ್ಕೆ ಆಗ್ತಿದೆ. Okay.
ಹಲೋ
ಸರ್, ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಿದೆ ಸರ್.
ಈಗ ಕೇಳಿಸ್ತಿದೆ ಸರ್?
ಈಗ ಕೇಳಿಸ್ತಿದೆ, ಬಟ್ ಲಾಗ್ ಔಟ್ ಆದ್ರಿಲ್ಲ. ನೀವೇ ಮಾಡಿದ್ರೆ which is going to be engaged by Dr. Ravikumar, Hosmani. And today's topic actually is the development of nano pesticides for the crop pest management. Sir, can you hear me? Okay. So today's training session is going to be engaged by Dr. Ravikumar, Hosmani, and the topic is development of nano pesticides for the crop pest management. Dr. Ravikumar right now is holding the position of assistant professor from the 2017 August and the present in the Institute of Agriculture Biotechnology IABT, University of Agriculture Sciences, Dharwad, Karnataka. Like the research assistant professor from 2016 January to August 2017 at NASA Ames Research Center, California, COSMI Research Center, University of New Mexico, UNM, USA, and the NASA's postdoctoral program fellowship he completed during the year 2013 to from the 2013 to 2016 from the NASA Ames Research Center, California, funded by the NASA headquarters, USA, and USRA postdoctoral fellowship from the 2011 to 2013 NASA Ames Research Center, California, sponsored by University Space Research Association, USRA, Columbia, USA. Dr. Ravikumar sir has actually completed his education PhD in the bioscience from the 2005 to 2010 from the CFTRI, Center for Technological Research Institute, which is an affiliate of CSIR from the Mysore. And he has completed the MSc in Agricultural Entomology from the 2003 to 2005 Chaudhary Charan Singh Haryana Agricultural University, Hisar. And Dr. Ravikumar sir has actually completed his BSc Agriculture from 1999 to 2003 from University of Agriculture Sciences, Dharwad. And Dr. Ravikumar sir has several publications, among which 17 are peer-reviewed research articles published, and the total citations of 506 and the index of 9. He's also delivered the 9 invited talks on the space biology and different research areas of the Dr. Ravikumar sir. It's an nanotechnology for the sustainable pest management and altered gravity as a novel tool for the crop improvement. And Dr. Ravikumar sir has handled the externally funded project. One is from the SDRBTS Government of India over 32 lakhs for 3 years, which was on hypergravity as a novel tool to enhance the germination and the seeding vigor in the selected crops as DI. And Dr. Ravikumar sir has also handled the ISRO Government of India recommended for first Gaganyaan unmanned mission space flight induced changes in the kidneys from formation in Drusilla melanogaster as a joint PI in collaboration with the Indian Institute of Space Science and Technology, Trivandrum. And Dr. Ravikumar sir has several recognitions and awards and scholarships to his credit. And the first of which is the University Incentive Award during the year 2019 for ad hoc grant received from the SDRBTS Government of India. And sir has also received the Master's Certificate of Appreciation during the year 2018 for the Fly Lab 192 ethical missions. To his credit, Dr. Ravikumar sir has also been the co-chairman for the invertebrate section 32nd ASGSR 2016 Grapeland Voyage, the USA, and the NASA's Ames Honor Award 2015 for valued team member with the Fly Lab 1 team, and Space Flight Awareness Team Award 2014 NASA's Human Space Flight Program, and Group Achievement Award of ARC Family 2013 the Excellence in Achieving the NASA's Mission. And NASA's postdoctoral program fellow 2013 present and ORAU Oak Ridge, Delhi, USA. And he has also been the co-chairman for the invertebrate session in the 28th ASGSR 2012 in Orlando, Louisiana, USA. And Dr. Ravikumar sir has had the postdoctoral travel grant during the year 2012 by COSPAR, the 2012, and he has also completed postdoctoral fellowship from the year 2011 to 2013 USRA Office of EAP, Columbia, USA. And Dr. Ravikumar sir has the best representation. Dr. Ravikumar sir has the best post presentation award 2010, SFRR 2010, Dharwad, India. And Dr. Ravikumar sir has also had the doctoral travel grant award 2008-12 European Transcendental Neurobiology Conference, University of Würzburg, Germany. And Dr. Ravikumar sir has also had the CSI UGC Junior Fellowship. CSI UGC Junior Research Fellowship from the year 2005 to 2010, CSI at UGC Government of India, and ICR Junior Fellowship, Research Fellowship from the 2003 to 2005, ICR New Delhi Government of India. At the undergraduate level, he also got the undergraduate merit scholarship in the year 1999 to 2003 from the US Dharwad, Karnataka. So this is the profile of Dr. Ravikumar sir, who is going to engage in the session of development of pesticide management, crop pest management today. Sir, now it's you can take charge and continue the proceedings of the day, sir. Dr. Ravikumar sir, please.
Can everybody hear me, right?
Yes, sir.
Yes, sir. It's visible and you're also quite audible, sir.
Okay. Thank you, Dr. Satyanarayanji, for giving a brief intro about me. And I just, before I start, as you said, I joined US Dharwad in 2017. And since then, I have been working on nanotechnology for the pest management. It's a very preliminary work we have done so far, and I'm going to highlight mainly on the work I have done. And of course, I'll take a little bit information from the literature. So the topic.
Ravikumar, sorry, sir.
Sorry,
Yes.
sir. Actually,
Can you put
can you put
the
the presentation in slide mode?
Yeah, it's in slide mode only.
Okay, fine.
Okay, fine, sir. Fine.
Yeah.
Is
it
not
slide
in
mode, right?
Right now, right now.
Okay.
Give slide.
Give slide, sir.
Slideshow.
Slideshow.
Yeah, that's what I've done actually, but I don't know.
That's fine.
That's fine. That's fine.
It
It is quite visible, sir. Now you can continue, sir. Please.
Sorry for the
disturbance.
Yeah. No worries. It's actually in the slide mode. So
Okay, fine. Sir.
So what I'm going to do is I'm going to very briefly talk about what is nanotechnology and the brief history of nanotechnology a little bit, and how the nanotechnology have been employing for the agriculture in general and then pest management in particular. So just to give you the nanotechnology in perspective, I'm not sure the audience whether many of them have a little bit of nanotechnology background. I thought it would be interesting to have a little bit perspective on the nanotechnology before we get into the crop management or pest management. So if you can see here in this picture, nanotechnology in perspective. So what is actually nanotechnology? It's nanosize. Nanosize is, as you know, it is 1 billionth of size. Obviously, human eyes can see to the limit of maybe 2 mm onwards, whereas the conventional microscope, what we use in the lab for the entomology work, that's any other purposes, those conventional light microscopes can be used to see the size of 200 nanometer and onwards. For example, sometimes you can see the bacteria. Bacteria are bigger than 100 nanometers, close to 1 micrometer. But the nanotechnology basically deals with the size of below 100 nanometer, 0 to 100 nanometer. So the reason why we are not able to see the conventional in the conventional light microscopy is obviously these microscopes are not able to go through the electrons. Electron microscopy is the only way out. We can easily see through these nanoparticles, which are below 100 nanometer. That's why after the invent of scanning electron microscopy, the nanotechnology area started gaining a lot of importance. So we all know that the DNA is pretty small, which is the diameter is around 2 nanometer, which is very, very small. And of course, if you want to go through the atom level, again, the atoms are 0.1 nanometer in size. So it's very difficult to see through all these nanoparticles. But in 1981 onwards, I'm going to go very brief about the history of nanotechnology in the next slide. But 1981 onwards, when the scanning tunneling microscope has invented, after that, a lot of these nanotechnology research has been gaining importance. So this is just to give the perspective. For example, we have the chicken egg or fruit flies. The most relevant one is fruit flies, which is around 2 to 3 mm in size, whereas nanotechnology deals with less than 100 nanometer in size.
Ravi sir?
Yeah.
Are you moving the slides now?
Yes.
But the chart box and even I cannot see the slides moving here, sir.
You cannot see that?
You can
scroll down.
Are you
scrolling down now? Because it got stuck in the first slide itself, it seems.
Okay.
How
about?
Now we can see the second slide. Okay, sir. Okay.
You can see the second slide now?
Of course.
Now.
Okay. So this slide I already explained. Next one is the next slide.
Okay.
Now third slide we can see, sir.
Okay. The history of nanotechnology, basically. So as I said, this is not a very new area of research. In fact, Einstein during 1905, he could able to visualize, not exactly the visualize, he could be able to assume or he could able to imagine the sugar molecule, which is less than 100 nanometer or even 100 nanometer. But actually, the nanotechnology history started from the very famous talk by Freeman, which is on the there is a plenty of room at the bottom in 1959. So basically, he was the one who started thinking about the importance of the nanoparticles, which are below 100 nanometers, and the scope of the nanotechnology in terms of.
Ravi sir, sorry sir. Actually, I'm repeatedly interfering. So the thing is that though you have put it in the slide mode, they have not come in the slide mode, and the images are very small. That is very here now. So what we'll do is that we'll they share the presentation here from here. So in the slide mode, slideshow mode, and you can give us the command like go next slide or something like that. Okay.
Okay. So you want to do that?
Just sure, because the images are here are very small now.
Okay.
Just sorry for the interference, sir.
No worries. I think let's fix the problem with the slide, and then we can go.
As you go further, like that will be a problem now. So
okay, what should I do now? Should I stop?
You stop the slide show, sir.
Okay. So you are going to share the slides?
Yeah, we can from here.
Yeah, you can try that then. Okay. I'll stop sharing.
Yeah, you please, sir. Please.
Yes.
Are they now in the slideshow mode, sir? Full screen?
Yes, they're in the slide mode.
You can tell us when we have to move the next slide.
Okay, sure. Okay, so the actual nanotechnology work started from the 1959 onwards, when the Richard Feynman, he gave a very famous lecture in 1959 on there is a plenty of room at the bottom. So basically what he's mentioning is he was talking about the scope of the nanotechnology and nanoscience in terms of medical applications, in terms of computer science, and in terms of manufacturing point of view. So then onwards, people started thinking about how to manipulate these atoms and molecules below 100 nanometer size, and can we make application out of that? So it started from there, and as I said in the previous slide, in 1981, invention of scanning tunneling microscope, that led to the revolution of nanotechnology actually. Because when you invent this scanning tunneling microscope, you were able to see these atoms. Earlier, people were just thinking and assuming that there are atoms, there are molecules. But when you see the scanning electron microscope under the scanning tunneling microscope, you will actually see these atoms and molecules and manipulate them the way you want. And can we make the product out of those molecules, those atoms which are below 100 nanometers, and combine them, make a product, and can we have the application from that point of view? So, of course, in 1974, the Japanese scientist Noriya Taniguchi, who coined the term nanotechnology actually. So, the major breakthrough or even major push in terms of nanotechnology came from the US in 2000. The National Institute of Nanotechnology initiative has started by the Clinton administration. Then in 2004, the Royal Society really showed that this nanotechnology can be used for medical industry in terms of developing some nanosensors, drug delivery for the treatment of cancer and other things. And since then, a lot of research is going on in terms of medical application of nanotechnology. We have currently few the drugs which are nano in size, and they have been employed in the clinical trials here in order to cure or in order to manage the cancer diseases. And after, of course, once you see the applications in the medical industry, a lot of people thinking about what is the environmental safety or what is the health hazard of these nanoparticles, because they were trying to use it for the medical industry. Obviously, the question was safety and bioethics from the picture. And 2016 onwards, people started thinking about how can we make sure that these nanoparticles are safe environmentally as well as health point of view. So that thinking started, But in the agriculture, application of nanotechnology in agriculture was very, very recent. In fact, I'm not going to go into the details of, of course, nanotechnology has been exploited for nano fertilizers, nano pesticides is one area. I'm going to talk about that. And there's a lot of agrochemical research is going on. But one thing you need to understand here is not many people are, for example, the companies I'm talking about, many of these companies like Syngenta and all those companies, they do claim that they are nano products, but of course they don't label it as nano products. So far, we have not seen any nano products out in the market for the commercial purpose. But I think the nanotechnology is in the very, very preliminary stage in terms of crop protection, as well as even for the agriculture point of view, in the laboratory condition only. The first report, next slide, please. Next slide.
Okay, sir. Okay, sir.
Okay, the first record of nanotechnology in agriculture was published by L. Bandry, who actually, what he said is the silica nanoparticles can be potentially used for pest management. Because the reason why these nanoparticles have a unique property is because they are very small in size, they can exhibit very unique properties such as the larger surface area, high reactivity, and photochemical properties, and all those properties are very, very important in terms of the biocidal effects. So the first record you can see here is published by L. Bandry, silica nanoparticles. What he has done is, you can also see in the figure A, the LC50 calculated by the probability analysis, and also see the mortality profile, where what they have done is basically they took the different concentration of silica nanoparticles from 100 to 350 nanometer, and you can see the concentration dependent mortality of Spodoptera littoralis larvae. So this is the first record of nanotechnology in agriculture pest management. So I'm going to talk about that in detail when we come to the nanoparticles from our own research in US Dharwad in the next few slides. This is just to give you the brief history about how the nanotechnology is using as a tool for better pest management. And it is a very recent area, because it's 2014 it has published paper actually. So that means it's only like 6 or 7 years old research, and not many people are started working on the field condition. It's only the laboratory studies. Many of these studies are laboratory condition studies, and we have a long way to go to put them into the field condition and see their efficacy in terms of phytotoxicity and in terms of environmental hazard, all those things. The next slide, please. I'm not going to go into the details of this one. You know that better than me in terms of pesticide consumption scenario in both India and world. In world, you can see the insecticide is only around 44%, whereas in India it is almost double. 76% is insecticides, and remaining 30% or 24% is herbicides, fungicides, and others. But actually, we don't need this much in terms of pest management is concerned, right? We don't have to dump 76% of insecticides for the better management of pest. That's where we have seen a lot of active ingredients lost in the environment. According to the one literature, what it says is if you put 100% or 100 ml of pesticides, or specifically the insecticides they are talking about, so what will happen is 50% will go away from the spray drift, and remaining 30% is going to be rolling down, and as a result of that, the insects will not be able to get the required concentration to kill them. And remaining 15%, again, it will go through the dust drift, 5% leaching. The actual concentration which is required to kill the insect pest is 0.1%. Just imagine 99.9% is going waste, and also it is contaminating our surrounding environment, as well as causing havoc in the health hazards and the health problem in the animals and human beings, right? So this is where the new and novel technologies come to the rescue, actually, because you can imagine 99.9% is wasting in the environment. Can we reduce that amount? Because it will have a humongous advantage to the farmers in terms of economics if you can reduce this loss. Especially we're talking about the rolling down percentage, right? 30% of the insecticides or herbicides you are spraying on the plant is going to roll down and get into the soil and it will contaminate water and soil, whatever it is, right? So can we reduce that one? Can we enhance the efficacy of these insecticides? So that's where the nanotechnology comes into the picture actually. Nanotechnology is one of the very powerful tool where you can enhance the efficacy of these insecticides by making them, by sticking them very comfortably on the leaf surface and reducing the concentration significantly. So the nanotechnology plays a very important role. So that's why I think the novel approaches are always very, very beneficial. Next slide, please. So what are the advantages of nanopesticides when you compare to the conventional pesticide, right? So of course, as I said, you can drastically reduce the concentration you are going to use it for the pest management, because you can reduce at least some percentage of environmental loss in terms of photodegradation or leaching or whatever it is. So as a result of that, you can increase the efficiency towards the insect pest by reducing the concentration significantly. Then another advantage of nanopesticides is you can have a controlled release actually. In the sense they will call it as a smart release pesticides. In the sense, if there is an increase in the temperature, you can ensure that these pesticides can be released only in certain temperature conditions. Certain pH conditions, you can release that. So for example, there are some products, they are not in the market, but there are in the published literature that clearly shows that when the encapsulated insecticides eaten by are consumed by these pests under the gut condition, because the gut is generally having a very high pH, right? So around acidic pH or basic pH. So whenever that specific pH conditions occurs in the gut, these encapsulated nanopesticides will be released in that. So you can have a control over when to release, where to release, and what concentration you can release that. So that kind of control you can have in nanopesticides, but you don't have that complete condition or that control over the conventional pesticides. And of course, because of the lower concentration we're going to use it, it will drastically reduces the risk of environmental contamination. And there's a very low chance of pest resistance because of, again, the lower concentration and very controlled conditions. You have controlled release mechanisms that will lead to the reduction in the pest resistance. Then solubility, we have some issues with the solubility in terms of current insecticides. We can also take care by using some of these nanopesticides. I'm going to give very brief about all these examples in the next few slides. Next slide, please. Okay, so coming to the real topic, that is nanopesticide formulation. We have a very popular research going on in terms of development of nanocapsules, and of course nanoparticles, and then we have the nanogels and nanoemulsions. These are the four formulations. A lot of research is going on in terms of pest management. If you can see the nanoemulsion, basically it is like water and oil kind of combination, but in the nano size. Okay, so whereas nanocapsules, you can have a core shell which is made up of any of the lipids or any of the polymers, and inside that you have these active ingredients entrapped. Okay, so that is nanocapsules. Basically, it can prevent the degradation of the active ingredients which is entrapped within the capsule. These capsules can be biodegradable. These capsules can be these capsules can have a controlled release. These can have a burst release, like depending on the temperature, depending on the pH. You can basically manipulate these capsules as the way you want and make sure that the insecticides is delivered in a specific condition. And of course, metal nanoparticles are another area where a lot of things the research is going on, including in our lab. So what is basically here is you take many of these metals like silver, gold, copper, zinc, and reduce their size to the nano, below 100 nanometer. And as soon as they get into the nano size, they will exhibit very unique property of biocide, right? They can kill the antimicrobial property is one of the classical example of silver nanoparticles, right? Because when you have the silver nanoparticles in the below 100 nano size, they can easily kill these bacteria, fungus, or many of the microbes. So people are trying to exploit whether the same metal nanoparticles below 100 nanometers can be exploited for the pest management, right? Whether they can kill the bigger insects like Spodoptera litera, the Helicoid parmigera, That is another area of research which is very actively going on. Next slide, please. I'm going to give an example of what we are doing currently in my lab at US Dharwad in terms of nano encapsulation for the pest management size. Of course, it's on the laboratory condition. As I said, many of the nanotechnology research in terms of pest management is still in the laboratory condition only. Maybe a few studies you can see in the greenhouse conditions, but definitely not many people are attempting in the field condition. So in the nano encapsulation, what we're doing is we're using something called liposome system. In the sense, what we're doing is we're taking these active ingredients and encapsulating with the lipids. These lipids can be, we're taking actually the soybean lipid, soya lipids, which are commercially available and very cheaply available. We take those lipids and encapsulate these pesticides and to make sure that this is having a slow release efficacy. Because we do understand, the nano encapsulation techniques is you cannot use it for quick fix of pest management. For example, if there is a huge outbreak of specific insect pest, you cannot use this nano encapsulation, right? Because these are slow release formulations. Because the reason why they wanted to do is they wanted to have a prophylactic pest management. In the sense, you can imagine there is a particular pest is occurring at a particular stage, and then you can take a spray. So you can take up a spray using this nano encapsulation, and it will have a very sustained release of active ingredients throughout the crop duration, right? So that's the reason why you have this nano encapsulation mainly with the slow release mechanism rather than the. Of course, you can manipulate them burst release as well as temperature dependent and pH dependent release can also be manipulated. But I'm giving an example of nano encapsulation which we have prepared in the slow release in our lab. Next slide, please. So if you look at the literature, the encapsulation using the lipids or using the liposome system, absolutely there is no literature on this in terms of if you go through any literature. But we did find in 2013 there is one patent by United States that clearly shows that the utility of liposomal formulations for the agriculture pest management. This has been patented by Watkins et al. In 2013. And after that, we have not seen much of the published literature on the liposome system. That's why we wanted to see whether we can use this liposome as a carrier material for preparing these liposome formulations for the pest management. So just to justify to prove this concept, it's a proof of concept basically, whether we can really have this encapsulation using the liposome, because there was no literature except that patent we had. So what we did is we took the profenophos at various concentration. Of course, we used the technical grade, and we tested against this Podoptera litra third install larvae. And again, the lipid source here is soy lipids and cholesterol. Soy lipids, which is commercially, we got it from the Sigma Chemicals. And we tried different concentration of soy lipids, like 2:1 or 3:1, 3:2, 4:3, 5:4 concentration of soy lipids as well as cholesterol. We used different solvents like dichloromethane, acetone, and methanol for the preparation of these liposome materials. I'm going to talk about how exactly we prepare these liposomes and what is the efficacy of those liposomes in the next slide. Next slide, please. So this is a very simple method of preparing the liposome encapsulated insecticide. So what you have to do is basically we have a lipids and the cholesterol combination. Cholesterol basically it acts as a stabilizer. Then we have the chemical which you want to entrap it within that encapsulation material, right? So we use the profenophos. Then you just mix it them, and then you have to dehydrate that using the vacuum rotary evaporator. So as a result of that, you can find a uniform lipid film at the bottom of the flask. So after that, you add some water or any concentration, any aqueous solution. So as a result of that, you can see the film will swell into form a vesicles, and profenophos trapped inside that. Okay. So the advantage here is basically lipid has an inherent property of forming a micelles, or forming a whenever it comes in contact with the aqueous solution, it will form a micelles or it will form a liposomes. Okay, that property of lipids we're exploiting here to entrap the profenophos inside that. So you can see in the picture, actually, this is the light microscope images we have taken immediately after the forming the lipids entrapped into the profenophos. As you can see in the above picture, this is just water droplets. Whereas in case of in the bottom picture, you can see those dark circle. Those are actually the liposomes, which are entrapped. The profenophos is entrapped within those liposomes, and they are varied size. Depending on because we are not mixed it properly, right? In the next stage, we are going to do the sonication. As a result of that, we are going to get the homogeneous population of liposomes. But you can see through the images in the microscope where these liposomes are entrapped within the profenophos is entrapped within the liposome system, and that you can easily visibly see that. So in order to get the same size, the idea is, can we make these one nanoliposomes, right? Now these sizes are very, very big actually, because of the when you can just imagine, you can see through the light microscope that obviously says that it is bigger than the 100 nanometer. So what we did is basically you sonicate them, these particles, then you are going to get the homogeneous population of liposomes. Then you have another filter. Through that filtrate, you just filter through, because this filtrate will help you to sort out the particular size of the liposomes. So this is the formulations we developed, which are below 100 nanometer. I'm going to tell you in the next slide. Next slide, please. So if we can look at this mean particle size using the particle size analyzer data, what we have found is, if you use the different concentration of soya phospholipids in cholesterol and different concentration of profenophos entrapped within the liposomes, only at 5:4 concentration of soya lipids and cholesterol, you have the nano size below 100 nanometer, 56.9 nanometer plus or minus 4.86, 0.1% is around 61.9%, and 0.5% is 79.2%. These are clearly indicates the nanoparticles we have generated, we have synthesized. These are liposome encapsulated and well within the 100 nanometers. Again, these three graphs, particle size analyzer data, which clearly shows that the mean size, mean diameter is 56.9, 61.9, and 79.2 nanometer. And also it will talk about the percent distribution. Almost like you can see here, 50% of the solution is less than 100 nanometer. So the whatever synthesis we have done using the liposome and then the entrapped profenophos into that are clearly 100 nanometer and less. Next slide, please. So we also wanted to see whether these nanoliposomes were able to, since we have already had an image of light microscope, because they are really, really big size. And once we did the particle size analyzer, we wanted to see through the nanoparticles or nanoliposomes under the scanning electron microscope. As you can see in this image, these two B and C are magnified version of the same image. The scale is around 200 nanometers here, and these small dots you can see on the surface of that background those are the nanoliposomes. Okay, those nanoliposomes, and when you magnify them, you can see that the ball of these liposomes and of course, as of now, we have no evidence that the profenophos is entrapped within that or not. We're going to talk about that in the next slide. But right now, at least you can see the ball of these liposomes in the spherical shape. Next slide. Well, I think this simple UV spectrum data will will give an idea about whether the profenophos is entrapped within the liposomes or not. Because profenophos is known to absorb at 289 nanometer. When you take the samples and put it in the UV spectrum, and you can see the bump at 289 nanometer size. That clearly indicates these liposomes did entrap the profenophos. Okay. And of course, you can do the HPLC method, the high performance trial. But even for using the UV spectrum, simple spectrophotometric reading also, you can easily see that the profenophos is entrapped within the liposome or not. Next slide, please. So then the next question is, okay, we confirmed the profenophos is entrapped within the liposome, and the liposomes are below 100 nanometer, and they are also spherical in shape. And the next question is, what is the in vitro stability of those liposomes, right? Because the idea is to generate these liposomes slow release formulation, right? Whether that slow release formulation is actually met or not, or whether the aim of our objective was to synthesize these nanoliposomes for the slow release formulation, right? So you can test that doing some in vitro stability studies. Of course, we call it as barrier diffusion method. So what we do is we take these dialysis bags, very simple dialysis bags. Again, you can get these commercially from the Sigma Chemicals and all, and other companies. You take a known amount of the liposome formulation, which you have synthesized in your lab, and put it in these liposomes. And again, that entire setup is put into a beaker containing methanol. Okay. So as a result of that, the active ingredients or liposomes within this dialysis will start dissipating slowly into the liposome, into the methanol media. Okay. And every day or once in 2 days, you take a certain amount of solution from the beaker and quantify through the UV spectrophotometer and see whether you can see the absorbance at 289 nanometer and plot that against the control. So as a result of that, what you can see here is the red one is indicating the red graph, and also you can see the error bars are very, very tight, indicating that there is very consistency in terms of replication. So you can see the red one is the profenophos alone, which is this is a percent profenophos released in the media. It is actually right. So you can see within 11 days, all the 100% profenophos or 100% profenophos within the liposome, within the profenophos active ingredients will be lost. Whereas in case of the liposome encapsulated, profenophos took almost 17 days, which clearly indicates the active ingredients within the liposome is slowly releasing, okay, compared to the only profenophos. And we also checked at the photodegradation. For the photodegradation, what we have done is just keep the entire setup outside the sunlight and take the reading every alternative days. And we took entire 17 days reading, and we were able to see again similar pattern. In the profenophos, active ingredients lost due to the sunlight within 11 days, whereas in liposome encapsulated almost took 17 days to exhaust all the 100% active ingredients in the laboratory condition. Next slide, please. This photodegradation as well as release rate clearly shows the very slow release from the liposome system. So then we look at the bioassay data using the leaf dip method. As you can see in the three different setup experiments we have carried out, 0.2%, 0.1%, 0.05% profenophos per se, and liposome encapsulated profenophos. And we also had a control where you have a blank liposome and just water per se and acetone. Acetone we used it for the leaf dip method. So that's why we took another control, that one. If you look at the bioassay data in the next slide, please. So when you look at the lipid encapsulated water versus lipid encapsulated profenophos, because we wanted to see the efficacy of profenophos in inducing mortality in Spodoptera littora. These studies has been done in the Spodoptera littora, third install larvae. And of course, in the lipid encapsulated water, we did get some mortality within 84 hours, almost like 15-20% mortality we did find in the lipid encapsulated water as well. Whereas in case of lipid encapsulated profenophos, 100% mortality was occurred as a dose dependent. You can see 72 hours and 0.1 and 0.5% profenophos induced mortality within 72 hours, whereas 2% mortality, 0.2% profenophos induced mortality within 84%. And we can see the mean survival standard mean and log rank test we have calculated all of
this topic actually is the development of nanopesticides for the crop pest management. So can you hear me?
The more interesting is here actually the profenophos per se versus
training session is going to be engaged by
and of course we have done the 0.1 and 0.05%, but I'm not going to talk about that data. Just to give the glimpse of how profenophos per se and how encapsulated 0.2% profenophos is inducing mortality differentially. slow release mechanism. Okay, of course we had the control acetone and liquid cholesterol encapsulated water. This has been used as anticipated. Around 15% mortality rates are there, and then water you don't find any much mortality there. Whereas what is interesting is 0.2% Profenophos per se, which induced mortality 100% within 36 hours. Whereas encapsulated, it took almost double the time, 72 hours. Right? So this clearly indicates the encapsulation does work in here. It does work because we were able to successfully entrap the Profenophos within that liposome system, and the liposome, because of that entrapment, because of that encapsulation, the lipids were slowly releasing these active ingredients from the Profenophos. And this is the mean survival as well as the hazard ratio also we have calculated. The hazard ratio, you can just see the hazard ratio 3.051 fold. What does it mean? The hazard ratio is basically the toxicity level. Toxicity level of encapsulated 0.20% Profenophos is almost 3.051% lower compared to the Profenophos. Profenophos was able to kill the insects 3 times more than the liposome encapsulated. That again indicates slow release mechanism of this encapsulated Profenophos. Next slide, please. Okay, so that is one of the work which is undergoing, and of course now we are trying to do we are trying to use that encapsulated liposome system for the greenhouse studies as well as field studies. In fact, one of our students got a BIRAC project on that, because we're trying to develop this as a product in case, if it is working in case of field studies as well as greenhouse. Using the greenhouse study as well as field studies, we have proposed that study to the BIRAC, Government of India, Government of Karnataka, and it got funded, and she's currently working on that, whether we can take it from the laboratory condition to the greenhouse and the field condition, and whether we can retain the same slow release mechanism in the liposome system. That is one area of work we're working on in the lab. And another one is green synthesis of metal nanoparticles for the pest management. So in this case, we're not doing any encapsulation or nothing, encapsulation or nano emulsions or nothing like that. It's only the metals we're taking. For example, in this study, what we have done is the green synthesis of silver nanoparticles. We took the silver nanoparticles using the green approach. Like, the silver nanoparticles can be synthesized using various methods, like chemical method, physical method, and biological method, right? Biological method is one of the safest methods. People say that because of the chemicals, the advanced chemicals, we don't use that. And also it is less expensive compared to the other methods. So in this case, what we have done is synthesized the silver nanoparticles using some of the plant extracts.
Sponsored by University.
Because the plant extracts are having a lot of these bioactive compounds. They can
Ravikumar sir has actually completed his education
particles.
PhD in the
They can
bioscience
easily
from
reduce the silver
2005 to 2010
silver ions
from the
in
CFTRI,
molecules or nanoparticles,
Technology
and
Research Institute
those
in the village of
nanoparticles can be
SIR
exploited
in
for the
Mysore.
crop management or
And
pest
he has
management
completed
that we have
the
tested.
MSc in Agriculture and
Next few
Entomology from the
slides. Next slide, please.
2005 Chaudhary Charan Singh Haryana
So
Agriculture University.
again, as I said, the reason why we are
And
focusing
today,
really on the
Ravikumar
silver
sir has actually
nanoparticles,
completed
although
his
we have
BSc
the
Agriculture
gold
from
nanoparticles
1999
and
to 2003
the
from the University
copper,
of
zinc, and so many
Dhaka.
other nanoparticles, metal
And
nanoparticles.
Dr. Ravikumar sir has
And there are a lot of oxides like zinc oxide, titanium dioxide, iron oxide.
Total citations of
But we are focusing mainly on the silver nanoparticles because there is plenty of literature on the silver
also
nanoparticles that
delivered
can
the
show
invited
it
talks in
has a
space
biocidal
biology,
property,
different
especially
research
the antimicrobial
areas of
property.
Dr. Ravikumar
So,
sir.
but there is
Nanotechnology for
absolutely
sustainable
no
pest
much
management,
literature
altered gravity,
whether the silver
carbon
nanoparticles can be
improvement.
used for the crop pest
And Dr.
management,
Ravikumar sir has
right? But we have the literature on
handled the
antimicrobial
extremely funded
property side,
project
but we don't have the nanopesticide
DRPTS
side. So we use that silver nanoparticles,
which was on
and
high
of course there is
gravity
very
and
few
then
literature that shows the larvicidal property, especially we have tested on mosquitoes.
as PI. And Dr.
For
Ravikumar
example,
sir
over
has
there
also
in
entered
2018,
the
we have tested the
ISRO
larvicidal
Government of
efficacy
India accredited for
in
first
the mosquitoes.
unmanned
But again,
mission space
that is from the
light-induced
point
changes in the
of
kidneys formation.
biomedical
Crossing melanic acid as a joint PI.
application
In
side.
collaboration with the
But again, the
University
people
of
have not
Space
tested
Science and
the
Technology, Trivandrum.
pest management.
And Dr. Ravikumar sir has several
And in this case, we use the
scholarships to his
leaf
credit.
extract for the
And the
reduction
first of which
process.
is the University Institute
We
Award
have
in the
this
year
leaf extract called
2019 for
ethanostasis,
grant
periwinkle will be
from the
these are
NCERT
basic.
of
So
India.
again, the reason why we
And
choose
sir
this
has also
particular plant
received the
there is again
certificate
literature
of
that says
organization
that
in year 2018
these particular plants have an insecticide
192
property.
conditions.
So if it is a combination of the plants which are having an insecticide property and
Dr.
the
Ravikumar sir has
nanoparticles or
also
metal nanoparticles which are having
Chairman for the
which are
invertebrate
potentially
session
possessing
32nd
silver,
AG
the nano
ASGSR
larvicidal property.
2016
It's a
the
very
brand
good
voyage,
combination to
the
try and
USA
see
and the NASA's
if there is any
Ace Honor
synergistic
Award 2015
impact.
for value team member
Because
by
in one
Lab
side the plant
1B,
extract itself
and
is having
Space
an
Flight Awareness Day
pesticide
for
effect,
2014
and
NASA's
the other side
Space Flight
silver
Program,
nanoparticles having
and
microbial
Achievement Award
antimicrobial
of
property.
ARC family
And when we
2013
combine those two
excellence in achieving the
and
NASA's
synthesize
mission.
using catharine
And
stroges,
NASA's
we're
postdoc
hoping that
program fellow
there should be
2013 present
some
and co-RP
enhanced or
report
synergistic
that is USA.
insecticidal efficacy.
And he has also
on that.
been the
And we
co-chairman for
tested
the
in Superopera
invigorate session in
again, these are
SGSR
laboratory
2012
studies.
in Portland,
We haven't
USA.
gone
And
until
Dr. Ravikumar sir has had the
field,
postdoc
field
travel
conditions.
grant during the year
Next slide, please.
2012 by COSPAR, the
So,
2012, and
although
he
there
has
are
also
a
completed
few
the postdoctoral
literature,
fellowship from the
if you
year
can see this
2011 to
one, the
2013,
literature,
USRA,
there
ISOP,
only
EJB, Columbia,
two literature
USA.
which clearly shows that the efficacy of these green synthesized or phytosynthesized silver nanoparticles have an ability to kill the
And
insects. For
Dr.
example,
Ravikumar sir
Putella
has
xylostella,
a
both of them
presentation.
are tested in Putella xylostella. Roni et al. By
Dr. Ravikumar sir
2015
has
and
the
Ali et al. in
Best
2019.
Post Presentation Award
Right.
2010.
But those two studies really shows the
India. And
phytosynthesized
Dr.
silver
Ravikumar sir has
nanoparticles
also
does have some
had
impact
the
on
Doctoral
the
Travel Grant Award 2008 12 European Transfer
these
Biological
Putella
Conference,
xylostella.
University of
But
Würzburg,
what we
Germany.
find is
And
there is absolutely no
Dr. Ravikumar sir has
literature
also
which
had
is
the
using
CSI UGC Junior Fellowship.
Of course, the project of Physiopora is very recently
CSI
occurred.
UGC Junior Research Fellowship from the year 2005 to
Probably that's the
2010
reason why
CSI UGC
nobody
Government
has
of India,
tested so far.
and ICR Junior Fellowship, Research Fellowship from the 2003 to 2005.
And we find
ICR
very interesting because
Government of
Putella
India.
xylostella was
At the undergraduate
having
level, he also got the
Putella
undergraduate
xylostella, these
scholarship in the
nanoparticles
year
were having very
1999 to
significant
2004.
impact, and we wanted to double check that
So this is
using the
the
other plant extract. That's the reason why we tested with both of these insects in our study.
management.
Next slide,
Crop
please.
pest management today. Sir, now it's
Okay,
you can
so
take
this is again a very simple
proceedings
protocol
of the
of
day,
green
sir.
synthesis of
Dr.
silver
Ravikumar, sir,
nanoparticles.
please.
What we have to do is basically you collect the fresh leaves and wash them thoroughly and
Yes,
grind
sir.
them.
It's visible and you're audible,
Then you
sir.
have a plant extract. Okay. Then you then you just centrifuge them
for giving
to some extent,
brief intro
maybe for
about
10-15 minutes around 6,000,
And,
7,000 RPM.
just before I
Then you
start,
filter
as you
the
said, I
after
joined
filtering
US
that
Dharwad in
all the
2017.
debris and all that
And since then,
will be separated,
I've been
and you have
working on
this
very
nanotechnology
pest management.
little bit of
It's a
golden
very,
color,
preliminary
the
work
extract
we have
you'll
done so
find that,
far, and I'm
and you can keep it that
mainly
for
on the work I have
6
done.
months,
And of
in the
course,
in the
I'll take a
refrigerator
visit,
at 4 degrees Celsius. Nothing will happen to
information
that.
from the
Then you take
literature.
whenever you want, and after that you add this Kg silver nitrate.
Sorry, sir. Actually, can you put this? Can you put
The
your presentation slide?
specific concentration silver
Yeah,
nitrate
it's
you
in slide
add,
mode
and
only.
initial color is going to be like
Okay,
this
fine, sir.
milky, milky and
Is it slide now?
turbid
Right now, right now.
solution color, and you keep it for
Okay.
boiling,
Use slide,
60
sir.
degrees Celsius for 30 minutes. We have done
Slide
that,
show.
and as a result of that,
Yeah.
this color changes
I've done
from
actually, but I
milky
don't know.
white
That's
to
fine, that's
dark
fine.
brown.
You
This is a
are-
typical
you say it is quite
indication
visible.
of
You can
formation of
continue, sir,
silver
please.
nanoparticles,
Sorry for the
because that is
disturbance.
another property
No.
in the particles,
It's actually in the slide mode. So
in the in general nanoparticles, because as they
So,
grow smaller and smaller,
what I'm going to
below
do
100
is
nanometer, 50
I'm going
nanometer, and 10
to
nanometer,
very briefly
they
talk
can also
about
change the color.
what is nanotechnology.
So
and,
that will clearly indicate
brief history of
the
nanotechnology
formation of
a little
silver
bit,
nanoparticles.
and
But
how the
we cannot
nanotechnology
quantify
have
them,
been
right? So that's why
employing
we have to go for the
in
next
agriculture in
characterization.
general,
And we
pest
know that
management in
visually
particular.
there is a formation of silver
So,
nanoparticles, but we,
just to
what
give
we
you
don't
the
know is
nanotechnology in
what size
perspective,
these are having and what
I'm
kind
not
of
sure
shapes
the
they are having,
audience, whether
and
the-
also
have
whether
any
the
of them
particle size
have a
distribution
little
is
bit of
more than
nanotechnology
50% or
background.
not.
It would be
That
interesting
needs to be
have a
characterized in
little
the
perspective on the
further
nanotechnology before we get
studies.
into the
Next slide, please.
the crop management or pest management. So,
Again, you can
if
also
you
go
can
to the
see here
same
in this picture,
same
nanotechnology in
methodologies.
What
we
is
have
actually
used for
nanothing like
some
characterization?
characterization.
Nanosize
You
is
can use
as
it
you
for
know, it's
UV
visible
spectroscopy and particle size analyzer
obviously
to analyze the
humanize.
particle size and
Can
the
see
distribution
to
and
the
the
limit of,
morphology,
maybe
and nanosize.
2 mm
You can go for
onwards.
the scanning electron
Whereas the
microscopy and
conventional
EX
microscope
what we use in the lab, microscopy in the FTIR, all of these things, any other need to do for the characterization. And the UV visible spectroscopy, you can see that again silver nanoparticles will absorb the size of typically between 4 and 20 nanometer to 450 nanometer. For example, if sometime you can see the bacteria range, that clearly shows that bigger than you have synthesized successfully close to 1 silver nanoparticles below 100 nanometer. The nanotechnology, whereas profenofos I was talking about, it will absorb size of below 100 whereas the silver nanoparticles will absorb at 422. So the reason why we are not able to see the conventional in the conventional light microscope. So again, you can see the visible UV visible spectroscopy data are not able to absorb at 4 and 48 nanometer maximums. So that clearly shows the only way out. There is a formation of silver nanoparticles, these nanoparticles which are below 100 nanometer. And of course, that's particle size, the particle size analyzer data clearly shows that almost 90% of the distribution is below 100 nanometer importance. So for example, what we all know that what it means is basically if you take 1 ml of solution, which is 90% of that solution is below 100 nanometer, and maybe after 10% is having more than 100 nanometer. Go to the atom level. Again, the atoms are maximum is 174.1 nanometers. It's very difficult to see through all these nanoparticles. That means only the 10% is in 1900 nanometers, whereas below 100 nanometers, below 100 nanometer next slide. But 1981 onwards, when the scanning tunneling microscope has invented, after that. So when you look at the scanning electron microscope images, you can see these are the nanoparticles. So this is just to give the most of them you can say it is a spherical example, and of course there are a couple of scanning. You can see the oval flights; those are the most probably because of the aggregation which is around happening in the 3 mm in size. While if you not really nanosonic really well, deals with the you can still see that aggregation happening there. But you can see the scale is 100 nanometer, which are almost half of the scale, which is around 48.9 nanometers.
But the chart box and
so in this energy dispersion X-ray spectroscopy, what it does is actually it gives you the elemental see that elemental information. Whether you take the sample
because
and
it is not stuck in the process flight itself.
which is the scanning electron microscopy. Okay. Then you can see through the percent distribution of metal you have used it actually. Like for example, we have used the silver nanoparticle, silver nitrate. We wanted to see whether the silver, how much percentage is there, right? So you can see here easy is silver which is around 23.7%. Next one is you can see the maximum is like almost carbon, oxygen and gold. AU is the history of nanotechnology. Carbon and oxygen is maybe these are compounds which is not a very new area of research. Or plant extract Einstein during that might have come. But the gold is of course for scanning electron microscopy. Not exactly visualize. What you have to do is you have to assume because these are electrically non-conductive. You have to make them conductive. So people use the gold sputtering on that. Actually, as a result of that, you see the gold also in the spectrum. But what it is important here is you can see the silver nitrate or silver metallic silver is there is plenty of room nanoparticles we have 1989. So basically, he was the one who started. And through this atomic force microscopy, what you can do is you can see the undulation, like morphology of these nanoparticles, scope of the nanotechnology, whether they are undulated in terms of their the surface is very smooth or not.
Sorry, sir.
But you can still this atomic force microscopy will give you the morphology and undulation of the nanoparticles. The undulation is not really big, which is again below 100 nanometers.
So what we'll do is that we'll the shape presentation here from here in the
so this FTIR is important actually,
and you can give us the command like
the FTIR analysis. What it does is all these peaks. Okay. So 1020, 2000,
because the images are very small.
These peaks will give you an information about the specific bioactive molecules present in the plant extract, which are responsible for. I think let's fix the reduction process and which are responsible for synthesis of silver nanoparticles. This will give you information about the bioactive compounds which are there. What should I do now? Those are probably responsible for the synthesis of silver nanoparticles. Okay, next slide, please. So you are going to share the slides? Again, we use the leaf kit method, which you all know. I'm not going to go into explaining all these things. I'll stop here. And because we have used this Podoptera frugifera, we took the castor leaf and we make them round discs and then we allow them to feed on the synchronized larvae of same age. Next slide, please. So this is what this we tested both in second and third instar larvae. Yes, you can see the
Are they
different
now in the
groups we have
slideshow mode,
tested.
sir?
We had a
Full screen?
control which is they are in water, and we had the plant
You can
extract
tell us,
tested.
like, when we have
And we
the
also
next
tested the
slide.
8,000 ppm Asian which is silver nitrate, and that is before started from the 1959. Then you also have the different concentration like 1,000, 2,000, 4,000, 8,000 ppm. Famous lecture. And we also use emamectin benzoate. Plenty of room at 0.25 grams. So basically, what he's mentioning is positive check. He was talking about and see how the nanoparticles and nano was comparable with the in terms of and of course, as anticipated, emamectin benzoate was manufacturing the entire second install larvae. So then onwards, people started thinking about whereas these nanoparticles, these atoms and molecules, almost below 100 nanometer size, and can we make application? It was not as effective as emamectin benzoate there, and as I said in the previous slide, in 1980s, emamectin benzoate is invention of scanning pure active compounds that led to the revolution of nanotechnology. Synthetic because compounds which can easily kill that. But nanoparticles were not as efficient as the emamectin benzoate, but definitely they are much better than the plant extract per se and the silver nitrate. When you see the scanning electron microscope under the scanning, for example, 8,000 ppm, you can see that these atoms and molecules and manipulate the insect second install larvae, and can we make 120 hours product out of those? But 1,000, 2,000, and 4,000 were not very effective atoms which are below 100 nanometers. But per se, when compared to the silver nitrate, it was much better from that point. Similar trend we observed, of course, in 1974. In general, third install larvae were much more resistance compared to the second install larvae, as you can see the graphs here. So many of them took a lot of time in major push, but they still induced mortality within 1 was came from the although the mortality rate was the very less, like 56% of the larvae were dead within 120 hours, which is anticipated because third install larvae are bigger and much more resistant. Really showed that these nanotechnology can be used for medical industry toxicity in terms of developing some nanosensors, drug delivery. Then what was important for us is we wanted to see how far these nanoparticles are comparing in terms of toxicity when compared to the AGNO3. AGNO3 is the precursor we have used it for the which are silver nanoparticles, and they have when you look at the hazard ratio and its log rank test which we have calculated using the graph in order to manage the cancer and both second and third install and after of course AGNO3 the 100,000 ppm AGNPs are silver nanoparticles. What is when compared to the AGNO3, toxicity was not significant in both hazard and install particles because that means AGNO3 is almost industry no toxic compared to the say 1,000 ppm AGNPs. Whereas 8,000 ppm use the highest mortality, it's almost like 11.2 sure that these nanoparticles toxic. Compared to the AGNO3 environmentally as well as and similarly in third install larvae we found 9.5 that thinking started toxic. But in the agriculture toxicity of nanoparticles was very AGNO3, which are highly significant. I'm not going to go into the details. Next slide, nanotechnology has been exploited for nanofertilizers, nanopesticides. Again, as anticipated, and when comparing with the emamectin benzoate, the hazard ratio is very low. To understand here, AGNPs, not the silver nanoparticles, were not as good as companies emamectin benzoate. Many of these companies reducing mortality, all those companies, both second install as well as third install, claim that they are nanoproducts like this, but of course they don't label it as a nano products. So what is interesting is in Pindala we got really interesting data. For the commercial you can see here, again we have the control plant extract and 4,000 ppm AGN as we have used here. We did not use the 8,000 ppm because Pindala size is much more smaller than the next slide please. So we thought we should have the lower concentration. Next slide, AGNPs here. And the highest concentration we have used is 4,000 ppm. The first record of nanotechnology we used 1,000, 2,000, 4,000 ppm silver nanoparticles and 4,000 ppm AGNO3 comparison. What and Corazin 0.3 ml per liter, which is positive check for us. What is interesting is both second and third install larvae. The reason why these AGNPs are highly comparable with the Corazin because they are very small in size. So that's where what I unique properties particularly think is the largest surface area, much more effective in terms of the smaller size, properties and all much more effective properties for the sucking pests in terms of not for the bigger insects. That's what our the preliminary study indicates. The smaller the size, much better these nanoparticles in terms of what he has done is you can also see in the you can see here the LC50 both corazine as well as 4,000 nanoparticles
and also see
reduced
the mortality
100% mortality.
Where what they have done
almost
is
like
they took the
more than 20 hours.
concentration of
The red one, the black one is 4,000 nanometer,
and you can see
whereas corazine is the square. This one is the literalized larvae. They are very, very comparable.
So this is the first record
mortality
of
and the
nanotechnology
trend
in
also
agriculture pest management.
And same trend was also observed
I'm
in
going
case
to
of
talk about
third install larvae as well.
nanoparticles
And third install larvae.
from our
Again,
own
the
research
mortality is,
in US
of
Dharwad.
course,
In the next few slides,
4,000
this is just to
little
give
less than the
brief
corazine, but it is highly
history
comparable in
about
terms
how
of, it is not like
the
emamic
nanotechnology
where within 24 hours it could reduce the mortality
using
100%,
as a
whereas
tool for
in case of
pest management.
120 hours,
And
it is a very recent area, mortality almost like 120 hours, right?
actually.
So
that means it's only like 6 or 7
in
years
Zalistella,
old
smaller
research.
insects, these
And
nanoparticles,
many
I
people
think
are
particularly
started
works.
working on
And
the field
we are planning to test it out
studies
with
many of these
sucking
studies are
insects.
laboratory condition studies.
In our lab,
And
I
we
have
hopefully
long
will
way
get
to go,
much better
to
data
put them
on
into
the
the smaller insects.
field condition
So
and
my
see their
understanding is
efficacy
that
in terms of
that is one of the
phytotoxicity
reason why
and
many
in terms
people
of
are
environmental
not
hazard,
trying out
all those things.
metal
The next slide,
nanoparticles
please.
on the bigger insects like Spodoptera litera and
I'm not going to
Fusiforme
go into the details of this one. You know that better than
Next
me
slide,
the-
please.
in terms of pesticide consumption scenario in both.
So again, you can see
world,
here we compare
you can
the
see
insecticide
is only
and
around
the different
44%,
concentration of AGNP.
whereas in India it is almost double.
much more higher
76%
toxicity
is,
of AG insecticides
and
and
remaining
pseudo nitrate
20% or 26,
Next slide.
24% is herbicides, fungicides, and others. But actually, we don't need this much.
Well, as
in
corazine,
terms of,
I think this is what I was
pest
talking
management
about.
is concerned.
So when you
right? We
compare
don't
the
have to
toxicity
dump
of 4,000
76% of
ppm
insecticides
for the with the
better
toxicity of
management of
corazine,
pest. That's
the result
where,
is non-significant.
we have
in
seen
both
a lot of
third install and
ingredients
second
lost
install. That clearly
in the
indicates the
according to
toxicity of
one
4,000
literature,
ppm.
what it says
silver
is,
nitrate, silver
if you
nanoparticles
put
are
100%
comparable
or
with
100
100
ml
ml
of
in terms of
pesticides,
mortality, inducing
specifically
mortality,
the
both second
insecticides
install
that
as well as
are
third install.
So what will happen
And that's
is
what
50%
we found
will go away
non-significant
in the spray
difference.
and remaining
those two.
30%
Groups.
is going to be rolling
Next
down, and as a result of that, the insects will not
All
be
right,
able to
so
get the,
those are some of the work
required
which is going
concentration
on
to
in
kill
our
them.
lab.
And remaining
we are focusing on
15%
right now.
Again, it will
Now
go
we
to the
have an
dust
idea
5%
that
leaching.
the
The
actual
nano concentration
encapsulation
required to kill the
protocols
insect
can be
pest is
utilized for
0.1%. Just
for,
imagine
slow release
99.9%
formulation
development
is
of
going
slow release
waste.
formulations, and also
And
it
these
is
nanos, the metal
it is
nanoparticles
contaminating our
can be utilized
surrounding
for
environment as well as causing havoc in
smaller
the
insects.
health.
It is much more effective in smaller insects
Health hazards
compared to the bigger
health
insects.
hazards
Having
and,
that idea,
the
we are
health
formulating
problem
some
in the animals and
some of the
human beings, right?
Some of the
So
plan of
this
work
is where the
to go in that
new
direction.
novel technology.
But meanwhile, I thought this is one of the interesting area for preparing the nanogels.
Can we reduce that?
Many of you guys have already seen the
humongous advantage to the benefit
published work by
farmers
the
in terms of
Department of
economics lab.
If we can
from
reduce
these
NBIR,
labs, especially
which
we're
are
talking
published
about
in
the
way back
rolling
in
down
2013.
these nanogels,
right?
again,
30%
it's a slow release formulation.
The
We are
insecticides
done
and herbicides
in
you're
case
saying
of
on the
liposome
methodology,
plant
right?
is going
So,
to roll down.
you can see the
and
methyl
get into
into
the soil and contaminate water and soil.
actually it is
whatever
colorless,
right?
When you use the
So
salt
can
cell
we reduce that?
method of
Can
preparation
we
of these
enhance the
nanogels,
efficacy of these
you
insecticides?
can see the
that's,
color
that's
change
where
from
nanotechnology
the
comes into the picture actually.
yellow to
Nanotechnology
the
is one of
close to the
very
red,
powerful tool
and
where
when
you can enhance
becomes
the
the
efficacy of these insecticides
solidified
by
this is
making
actually
them
inverted,
sticking them
very
inverted
tubes
comfortably
where you
on
can
the
see
leaf
the
surface
when it is
and
formed
reducing
the
polymerization
polymerization
significantly. So
gelatin-
the nanotechnology
gelatinization
plays a very important
become
role.
really,
So
really
that's why
thick
I think
and,
they have
novel
seen
approaches
the
are always,
efficacy of these slow release
very, very
nanogels.
beneficial.
Next slide, please. In terms of pheromone efficacy.
Next slide, please.
So, what are the advantages of nanopesticides when you compare
Okay,
to
so
conventional
this
pesticide, right?
this has been
So
published
of course,
in scientific
as I
reports,
said,
you know that.
you can drastically
you can
reduce
see
the
in this one
concentration you are
the
going
number
to
of
use it for the
catches
pest
of
management
food
because
pests,
you can reduce at least some
I think,
percentage of
so up
environmental
to
loss in terms of
21 days
degradation,
they were able
bleaching
to
or whatever it
retain
is.
the
So as a result of that, you can
efficacy.
increase the
in
efficiency
towards
the
the
orchard.
insect pest.
Whereas
by reducing
the
other
concentration
than nanogels, other than
then another advantage of
nanopesticides, they could able
nanopesticides is
to
you can have a
lost
controlled
the
release
pheromone
actually.
efficacy
In the
within
sense
7
they will
days.
call it as a smart release.
So this is what you can,
pesticides.
with the
In
same
sense,
concentration,
if there is an increase in the temperature,
and you can
ensure
really,
that
really slow
these
them.
pesticides can
Release
release
of these
only in
pheromones
certain temperature
from
conditions.
the using these
certain
nanogels.
pH conditions.
This is
you
one
can use
area
that.
which is
For example, there are some
focusing on.
products
I think
they are not
in the
because of the
market.
time
but there are
time I'm going to
stop it in the next 1 or 2 slides, and then we'll take the more questions
insecticides
and we'll discuss about this topic. Next slide, please.
Are consumed by these pests.
Okay,
Under
so
the
the
overall,
condition, because gut is
as I said,
very high
the
pH, right?
nanotechnology
So,
for the pest
acidic
management is
pH
in
or
the
basic
very, very
pH.
preliminary
So
stages.
whenever that's
And
mostly,
mostly
I would say
there is
lab conditions.
not many people are
will be released in that.
working
So you can
in the
basically
field
you can have
conditions
a
or
control
greenhouse
over
conditions.
when to release,
Again,
when to
because
release,
of
and
the
what concentration you can release
because
that.
of various
So that
other
kind of
reasons.
control you can have a
But what we have
but
found
you don't
is
have that
we
kind of
know that
condition,
you can
that control over the conventional
actually
pesticides. And of course, because of the
cost of this
lower
one.
concentration,
And also we
when
know
you
that
use it,
you can
drastically reduces the risk of
nanopesticides
contamination
by using various
and
nanoformulations.
there's a very
But
low
what
chance
is
of pest resistance
debating right now
because
is,
of
again,
economic
lower
viability
concentration
and
whether
very
whether
controlled
the
conditions
process,
you have
for example, in
controlled
case of
mechanisms
liposome,
that
right?
will lead to the
Because you're adding the cost
reduction in the pest
to the
resistance.
already existing pesticides.
Then solubility,
whether it is
we
going
have
to be
some issues
economically
with
viable or
solubility
not,
that
in
needs
terms
to
of
be
current looked at.
insecticides.
And the social
We
acceptance,
can also
because
taken
so far
care
we don't have
by
the,
using some of these
the
nanopesticides.
regulations.
I'm not
derived
going to
by
give
the
very brief
government of India.
about
And of course, in
all these
2019,
examples in the next
the Department of
few
Biotechnology
slides.
did come up with some
Next slide,
regulations, which is already
Okay,
under the
so
process.
so
But
coming to
we have
the
no
real
idea
topic
how
is
the
nanopesticide
society in general
formulation.
will accept these
We
technologies
have
in
a
terms
very
of pest
popular
management. Maybe the awareness
research
is
going on
one
in
big
terms
issue.
of,
And we also
development of
have no
capsules
idea about their
and of
environment
course
footprint.
nanoparticles.
In the
and then
sense, we have no idea about the phytotoxicity of those
These are the four formulations.
nanoparticles and what is
A
the
lot of research is
accumulation
going
of
on,
these, especially
in
silver
terms of,
nanoparticles
pest
or
management.
other
If you can see the nano
metal nanoparticles,
like
whether they are
working
going to
quite
have any
kind of,
impact on
combination,
those.
but in the nano
And
size.
the
Okay?
scalability.
So,
Scalability is whether we can
whereas
increase the
nanocapsules, you
number
can,
of
you
whether
can
we
have
increase
a
the
core
size
shell
in
which
terms
is
of
made up of
tons
any
of
the
the nanoparticles.
any of the
Can we
lipids or any of the polymers, and
can we
inside that
scale
you
up
have
to the
these active ingredients entrapped.
chemicals which are required by the
So that is
farming
nanocapsules.
community.
Those are
Basically,
some
it
of the
can
issues,
prevent the degradation of
the
the
active ingredients which is entrapped.
But I think
into
in general,
the
for the pest
capsule.
management,
These capsules can be biodegradable.
right direction.
These capsules can
But
be.
these are some of the points needs to be
These
taken
capsules
care
can
of.
have a controlled release.
Footprint,
These
society
can have a
acceptance,
burst
economic
release,
viability.
like depending
So,
on the temperature, depending on the
as
pH,
we
you can
progress
basically manipulate
forward,
these capsules
hopefully
as
we'll get more
as
and
the
more
way you
clarity
want
in terms of
and make sure
these
that
areas
the insecticides is delivered in a specific
how far these
condition.
nanotechnology
And
is
of
going
course,
to be revolutionizing
metal nanoparticles
pest
are,
management
another
aspect.
area.
So I think I'll stop it here.
The research is going
I'll
on.
be happy to
including
take
more
a few
of that.
questions.
So what is basically here is you take the
Next slide.
many of these metals like silver, gold,
Thank you.
copper,
Yeah. Okay.
zinc,
Yes.
and reduce the
I'll be
size to the nano.
Okay, sir. Thank you very much for your wonderful
And as soon as
presentation on the
they
benefit
get
of
into
nanopesticides
the
for
nano
process
size,
management.
they will exhibit
And I
very
request
unique
audience like if
properties
they
of
got
their
any
cells.
particular queries
They can
regarding
kill
the
the
particular topic,
antimicrobial
so you can
properties,
just
which is one of the
ask Ravi sir.
classical examples of the nanoparticles.
There online.
Because when you have the silver nanoparticles in the
Topic
below
is
100
open
nano
for discussion
size,
now.
they can easily kill these
Hello, Dr. Ravikumar.
bacteria, fungus, or many of the
Case
microbes.
from
People
Directorate
are
of
trying to
Horticulture
exploit
Research,
whether the
Pune.
same metal nanoparticles below 100
While
nanometers can
dealing
be
with
exploited
this
for pest management.
Rutella
Whether
xylostella,
they can kill the bigger
you
insects.
told about
like,
they may be very effective against the
Agril or
sucking
Parmigiana.
pest.
That is another area of research.
Have you done
which is
any
very actively
bioassays against
going on.
any of the sucking pests?
Next slide, please.
No, that's what I think.